Hey, what's up guys? So this video is going to be about extremas on an interval. This is the first lecture in the series Applications of Differentiation, so I hope it's helpful. Alright, so first I want you to do is think about this word extrema, okay? When you see this word extrema, what is a word that's very similar to extrema? So extrema, maybe pause the video and think about it. That word is extreme, okay? So what would be the extremes on an interval in calculus? Well, the extremes are going to be like the maximum or the minimum, okay? So when we're talking about extrema here in calculus, we're talking about the maximums and minimums of a graph, okay? And how do we use calculus to find these maximums and minimums, all right? So here's a graph, for example. Clearly this is a minimum and this is a maximum. And we're going to use calculus to find these. So you're going to have two types of extrema, right? You're going to have what we call relative maximum and minimum, or absolute maximum and minimum. Now relative is kind of like local, so you might see this word local used in place of relative, and absolute is like global. So look here at this picture. And I want you to notice for a second where you have relative and where you have absolute, okay? So notice here, you have a relative max here and here. You have a relative min only here, okay? And then you have an absolute max located here, and an absolute min located here. Okay, so what I want you to do next is I want you to pause this video and I want you to think and try to do this as mathematically correct as possible. What is an absolute maximum or minimum, and what is a relative maximum or minimum? Okay, so pause this video and try to think about what is the difference between the two. All right, and try to make your definition or your answer be as kind of mathematically precise as possible. All right, pause the video and do that, please. Okay, so I hope you've already paused the video and thought about this for a second. So this is essentially what is happening. Okay, so when we're talking about an absolute max or minimum, so the first thing we want to think is an absolute maximum or minimum occurs over the entire interval, okay? So entire interval, all right? So it is the biggest or the smallest of all, right? The largest or the smallest, okay? The biggest, I don't know how I'm going to fit the word smallest. Small, right? Small. All right. So the biggest or the smallest of all. Okay. So when you're thinking about absolute, you think about the word global, right? So global is over the entire interval. Now relative is a little bit more tricky. Notice this relative max, relative min, relative max, and then neither at these endpoints. Okay. I think the best way to remember the relative max or min is to think about relative max or min can only occur when the function is changing, okay, from increasing to decreasing, or decreasing to increasing, which I'm just going to write the word vice versa, which of course means the opposite, increasing to decreasing, okay? So a relative minimum or maximum is local, all right? So the function needs to be changing from increasing to decreasing or decreasing to increasing, okay? Now over here you can see you're just increasing. So actually this is kind of a funny thing because some calculus books actually want to say that this is a relative minimum. All right. Now, I think mathematically it's not a relative minimum. And if you look on Google and you do a little search in any mathematically rigorous book, I think you will find that they do not list this as a relative minimum. For the AP, sometimes they will say relative minimum, okay? But for the AP test, okay, I'm sorry, when I say for the AP, I mean in the AP books. Some AP books I have seen refer to that as a relative minimum. Now, on the AP test, this will never be a point of confusion, okay? Let me allow you to see me real quick. All right, so on the AP test, this will never be a point of confusion. I guarantee they will never ask the endpoint, is the endpoint a relative minimum or not, okay? This is not going to be a question, all right? So if you talk to your teacher and ask him what he wants for the test, all right? Again, on the AP test, it's not going to be ever going to be a question. Okay, I can 99.9% guarantee you that. Okay, continuing along. So think about this for a second. All right, what I want you to do here is I want you to pause this video and think about what is going to go in each of these blanks. Okay, so I hope you pause this video, and I'm going to reveal these answers in 3, 2, 1. All right, so I hope you already wrote this down, and function decreasing to increasing, right? So it's going to be something like this, or it might be like that, and then increasing to decreasing, or something like this. Not like that, sorry. Something like... Oh, can I undo that? No, sorry. But I think a function relative maximum could be like that or like that. Okay, so hopefully you already got the chance to write that down. If not, rewind the video. Let's move forward. So next thing we're going to do is we're going to talk about critical numbers. All right, critical number. So what is a critical number? Okay, a critical number is an x value where there could possibly be a maximum or minimum. Now, there's not definitely a maximum or minimum, but there could possibly be a maximum and minimum here. And it's very important that you learn to find critical numbers of a function. Okay, so where are critical numbers? Think also what the word critical means, right? The word critical means something that's very important. Okay, so what are the important numbers or the important x values of a function? And there are going to be two places, okay? So let f be defined. The point x equals c is a critical number if f prime of c does not exist or f prime of c equals to 0. All right? So those are the 2 points where you might have a critical number. Okay, and what do I mean? Well, I mean here, okay? Here is a critical number or a critical point. It's the same thing. A point would just include an x and a y. But critical number at c in both of these situations. In both of these situations, you have a relative maximum. Okay. Here, f prime of c does not exist, and here f prime of c equals 0. Okay. So again, critical numbers where the derivative does not exist or the derivative equals to 0. All right, so now we are going to do 4 examples here, okay? In each of these examples, you're going to find the critical number, and then you're going to use your calculator to graph it, and then just tell me at that critical number, do you have an absolute max or min, a relative max or min, or a combination of the two, okay? So the first one we're going to do is going to be f of x equal x cubed minus 12x. Go ahead and pause the video, see if you can find the critical numbers, okay? Remember, critical number where the derivative equals 0 or the derivative does not exist, and then graph the function with your calculator and then figure out, do you have a relative or absolute max or min? All right? So go ahead and pause the video and do this now. All right, so hope you already paused the video and tried it yourself. So how to find a critical number? Well, first you need to take the derivative, okay? So the derivative of this is 3x squared minus 12. And then you need to think about 2 things. 1, where does this equal 0? And 2, where does this not exist? Well, notice this is a polynomial, 3x squared minus 12. Polynomials, the domain, are all real numbers. It's going to exist everywhere. Now, where does something not exist? You're looking for where you're dividing by 0 or you're taking the square root of a negative. Okay, that's what we're looking for. So anyway, here, let's continue. So it does not exist. It exists everywhere. Where does this equal 0? Well, where 3x squared equals 12, where x squared equals 4, or where x equals plus or minus 2. Okay, so you have two critical points, at positive 2 and at negative 2. And now the next thing you're supposed to do is graph this with your calculator. Well, when you graph it, you're going to see here is negative 2. Okay, and so how about that negative 2? Well, it looks to be that's right, relative max, right? Increasing to decreasing, but not an absolute max. I mean, this graph continues here going on and on forever. Okay, and at positive 2, we're going to have a relative min. So relative max only, relative min only for this one. Okay, next one. Relative max and relative min is what you want to write there. All right, next one, x minus 3 to the 2/3. Again, pause the video, find the critical numbers, graph it, and figure out what they are. All right, so critical number, we're going to take the derivative. Okay, by the way, make sure you pause this and try this by yourself. Okay, so the derivative is just going to be 2/3 x minus 3 to the negative 1/3. And now let's rewrite this to make this a little bit easier to find. It's going to be 2 over 3. X minus 3 to the 1/3 is just the cube root of x minus 3. Okay, so we're going to figure out, where does this equal 0, or is there anywhere where it does not exist? Well, this is never going to equal to 0 because we always have a 2 on the top here. Now, the bottom can be 0, which means this derivative does not exist wherever the bottom, right, equals to 0, wherever 3 times the cube root of x minus 3 equals 0. Well, divide by 3, right? So you get the cube root x minus 3 equals 0. And so then you're going to cube both sides to get rid of that cube root. So you're going to get x minus 3 equals 0 and x equals 3. Okay, so that means you have a critical point at x equals 3. Okay, critical number at x equals 3. And now when you graph it, take a look. You have x equals 3, you have this one, and this is going to continue. So this is both an absolute and a relative minimum for this problem. All right, let's do another. Same question, but now you're using the cube root of x. So please pause this video and give it a go. All right, so the cube root of x. Easiest way to take this derivative is right at x to the 1/3. So what are you going to get? You're going to get that the derivative is 1/3 x to the negative 2/3. Rewrite this to make this easier. 3 times the cube root of x squared. Okay, this is never going to equal to 0, but it is going to not exist whenever this part is 0. When is that 0? Well, when x equals 0. So therefore, we just have one critical point at x equals 0. Use your calculator, graph it, and you look here, and what do you notice is actually this critical point is neither relative or absolute max or min. Okay, so this is very interesting. Here it is, a critical point where it's neither. Now remember what I said. I said a critical point is a place where you can possibly have a max or min. Okay, not guaranteed. All right, so let's do one more and then we'll be done for this video. This last one is going to be 5 over x minus 4. Pause the video, give it a try. All right, so I hope you paused this video. So let's do the derivative. F prime of x is going to be, well, first off, let me rewrite this. 5 x minus 4 to the negative 1. Make it easier to take the derivative. So what's it going to be? It's going to be negative 1 times 5. X minus 4 to the negative 2. Let's write this, negative 5 x minus 4 squared. So where does this equal to 0? Well, this is never going to equal to 0. And where does it not exist? Well, this is not, this does not exist whenever this bottom is 0. So whenever x equals 4, f prime of x does not exist. So this is an interesting problem. Is x equals 4 going to be a critical number? Well, let's graph it, and I want to show you something. Notice x equals 4, you will have a vertical asymptote here. Okay? Why? Well, x equals 4, the function at x equals 4 gives you a 0 in the denominator. So actually, f of 4 does not exist. Okay? So x equals 4 is not a critical number. Therefore, for sure, you do not have an absolute max or min there because the function doesn't exist there. Okay? So keep in mind the fact that f of c must exist in order for it to be a critical point, and it must be a critical point in order for it to possibly be a relative max or min. Alright, so that wraps up this video. The video on critical numbers and absolute and relative max and mins. So we'll talk a little bit more about this in the videos to come. And I hope this was beneficial and you enjoyed the video. So thanks for watching. Bye-bye.